All right, what's up, guys? So just watch this video before you take the quiz today. I just want to cover some things. So I'm going to share whiteboard. Okay, so here's what we're going to do. We're going to talk about what you need to know or what you should we should know. I mean, you have the list from last class, but the important thing is this. Let's start with our the key here is know the difference between distance versus displacement. Distance and displacement. So the key is this, understanding the difference between scalars and vectors. So scalar is just a number. Vectors are a number and direction. So that's a difference. So what we know is one of these, distance and displacement, is a vector. One of them is a scalar. So we know that distance is a scalar and displacement is a vector. So what that means is this. Distance, the definition, is just how far did you travel, while displacement is how far are you from where you started. So if I think about this, this is the thing I did in class. If I start in here and walk 5 meters this way, my distance is 5 meters. My displacement, which is delta x, is, let's call this positive 5. Let's call this way positive, this way negative, okay? Then if I turn around and walk this way and I stop right here, I now know my distance is 10 and my displacement is now 0 because I'm back at my starting point. Now, if I keep walking 5 more meters, I know at this point I've walked 15 meters and my delta x is now negative 5 meters. Because from where I started, I'm to the left 5 meters, okay? So that's the difference to this. It's all same in meters. All the units are same, meters, 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 okay? So that should be very easy. Now, how you compare this is now, or what you're going to use this for is speed versus velocity. All right, these equations are on your quiz and they're on the board. So speed is just distance over time, while velocity is displacement over time. And we can expand that out to x final minus x initial over time. These are both in meters per second as our base unit. And this one is always positive because it's a scalar, and this one has a unit of direction, so it can be positive or negative, okay? So what's important here is to understand that to find the speed, you use distance. To find the velocity, you use displacement. All right, and then you just plug in and solve there. It's actually relatively easy. Okay, let's see. Let's do a conversion thing. Let's just do a practice converting. Let's say I have 12 kilometers per hour. You're going to have to do this conversion here. So if I do this conversion, I want to go to meters per second because that's my base unit. So if I look at this, I want to get rid of kilometers. I put it on the bottom. 1 kilometer, 1,000 meters. That conversion factor is on the board. There's a lot of information on the board up there. All right, and I get rid of hours. 1 hour is equal to 30 seconds. And then I would do cancel out, cancel out, cancel out, cancel out. And I'm left with meters per second. So what you do is you do 12 times 1,000 divided by 3,600. Let me get a calculator real quick so you guys can just double check your answer. 12 times 1,000 divided by 3,600 gives me 3.3 meters per second. Okay, that's just an example of converting, so you have it. The key is pay attention to what they're asking the units to be. So your options are this. You can convert first and then plug into the equations, or as long as the distances and the times match up with all the variables. So the only thing you have is distance over time or velocity is displacement over time. So as long as this is in meters per second, this has to be in meters, this has to be in seconds. If this is in kilometers per hour, that means this has to be in kilometers, that has to be in hours. So they got to match up. You can't mix them up. All right. So you pay attention to what they're asking you to find. Okay. Or what they want the answer to be in. Because that will help make sure you get the right answer. All right. I want to do a real quick little practice here. Let's say we have a guy. He walks fast for time equals 10 seconds, and he goes a distance of 30 meters. And let's say he stops for 15 seconds and walks slowly back, start, let's say 25 seconds. And what you're going to be asked to do is calculate a displacement versus time graph. Okay, so let's think about this. We know that the total time, he's going to start walking 10 seconds, he stands still for 15, and he walks another 25. So we have a total of 50 seconds. So total time equals 50 seconds. So I have to make a graph here, or a scale that will show my time. So I just made that. My total distance, the furthest he goes is 30 meters. So let's do 30. Okay. So let's see. He goes 10 meters. So I go, or in 10 seconds, he goes 30 meters. So I'm going to put this here, and I put a point here, because at 10 seconds, he's 30 meters. I know he starts from the start and he goes like that. Then for 15 seconds, so from 10 to 20 to 25, so let me say 25 is right here, right? He stands still. How do I represent him standing still? Well, he stays at the same distance, right? If you're standing still, you're going to stay at 30 meters. So I'm going to represent that. Then he takes 25 seconds to go back to the start. Well, he started here, so it means in 25 more seconds, it'd be 50 seconds, he would come back to this point. So I'll draw a line like that. That would be your graph there. Okay, so just make sure you look at the given information and use that to build your graph. Okay. I'm gonna stop sharing here.